So let's see what's in this transformer and see if it's fixable. Let's see if we can get it to come apart here. I think Lionel was pretty responsible in making these things hard to take apart, so people didn't try and repair them on their own and electrocute themselves or whatever. Should have tested this before I even started. Well, quite honestly, it looks like it's all there. Nothing looks burnt or anything like that. I think that's for the whistle. There we go. Just going to clean that up. So this here, I think it's for the whistle, and there's a diode in the bottom there, and what that does is give you a 5-volt DC offset to make the whistle work. But that's a pretty sticky shot of WD-40 would work on that. I just remembered that my can of WD-40 actually quit spraying. There's no pressure left in it. So I took the contents of it, put it into a small bottle here. It's already operating a whole lot smoother. So we can use this and just put some drops in there. Kind of making a mess out of it, but that's alright. Alright, so that seems to be working pretty good, a lot smoother. I'm going to bet the diode that's in the bottom there, I'm going to bet is bad. They deteriorate. It's just a disc about 1 inch in diameter. It's a funky kind of old technology diode, and I'm going to probably have to take this all apart, but at least that slides up and down the way it's supposed to. So the next thing is, let's take apart this switch here, because that really doesn't seem like it's working. The reverse switch, or that operates the E unit. Okay, other than the fact that these contacts in here, I don't know if we can see that, there's 2 contacts that look like they're in pretty bad shape. I have to find a small file, clean those contacts. Here's the button that goes in there. I'm going to clean that in the sink, and I'm going to have to do this off camera because I'm not going to be able to do this while it's on, and I need to remember to put the insulation paper in there. So I did some testing on this, and just as I suspected, the reverse seems to work. If I go back to AC here, we got 12.5 volts. If I press the red button here, then it goes to 0, which will activate the E unit, or reversing unit. So basically the transformer works, the reverse will work. There's an A, a B, and a U, and I believe that the U is the common that I have connected here. The B I thought was for accessories, but I'm not getting a voltage on that, so I don't know what's going on. Let's switch this to DC. It's still not going to give me a reading on the B terminal. So I have to do a little research on that. But basically, the reason I bought this for $2 for a testing transformer when I'm down here in the basement and I got something I want to test. Okay, so I took this apart here, and this right here is actually a diode, this disc. It looks like a washer. One side is coated with something, and so basically it works as a diode. But it looks like it's okay, other than you see how that's kind of greenish color there, that pin. So, and it's the same way on the other side here, if we can see that, the other side of that pin is also green, so it's probably not making contact, so that is not working. So if I take that apart, I might be able to save that diode. And I was showing you that the B terminal did not work, and when I took this apart, realized that it's not connected to anything. So I need to figure out how to solder that on there. So let's talk about this diode here. This one seems to be working. I did test it, and what that does again is it's a rectifier diode that gives you a DC offset to make the whistle work. When it goes bad, you have to replace it. Now I think you can still buy them from Lionel or other suppliers, but it's kind of, if you want it to look authentic, you can replace it with an original, or you can just put a regular diode in it. You can buy one of these that's like a 16 amp diode, and the problem with most power supplies is that it won't fit. And this one, there's probably enough room to fit that in there, but it would still be a snug fit. Then you have to bend this part down here. So that's a 16 amp diode. Or you can get one of these. You can get these up to like 10 amps or something, which will do the trick. So you can see the size of this here in comparison. You get one 6 amps. That's more than enough. I mean, you realize the breaker in your house is 15 amps. So if you had anything close to that going through there, if you even had 10 amps going through there, and you had 2 lights on and maybe a fan, you'll be blowing circuit breakers all day. So I'm going to show you that there's no way it uses anywhere near 16 amps. This one's working. I'm not going to change it, but if I had to, I would use something like this, and that would work. Okay, so I'm going to hook this power supply up and give it a test here. What I like to use for wires here is I get cords like this from computers or whatever. I have tons of them at work. And I cut both ends off and then strip the wire out of it, and you get this heavy, it's usually like 18 gauge wire, which is pretty good. And then what I do, take the end of it here and I solder that just on the end. So in other words, if the solder follows it down too far, you just cut the end off, because you actually want the terminal to contact the copper, not the soldered part. So when you put it in there, you put it in far enough that it contacts the copper and not the solder. And what that does is, if you pull them out or change them around or something, it keeps it from the ends fraying and constantly having to cut the ends and redo them. Okay, so I got this hooked up to a piece of track there with a coal tender on it with a whistle. So we give this some power. There you go. So I guess I need to take this up and connect it to the track and make sure it actually powers the locomotive. I talked about the diodes and how much current this is actually going to draw. So we've got the power turned up a little bit here. So how much current does a whistle draw? That is okay, that hit 0.6. 0.7, so that is 700 milliamps. That's less than an amp. Most of that happens when you activate that relay in there. Okay, we had 0.8 on that one.
still never over an amp. So clearly no need for a 16 amp diode.